Okay, good morning, everyone. Almost good afternoon. I'm going to, this screen shows you the one that we have done last week. I am going to review a little bit of those. Um, when you open up your playground in Swift UI, you will have two files. This file indicates to display the content view. This is another file. So if you go to that content view, then that is in struct form. Content view is a view. So colon and a view, then this is a type of this content view. This is a current file, which is the type of view. So in other words, if we say in object orientation, then view is a superclass and content view is a subclass. Or in general, content view, type of content view is a view. If you look inside, then there is a body. This body shows a sum view in a vertical stack. So they are all in vertical stacks. As you can see here in this, the emulator, they're all in vertically aligned. If we count the number of lines, then you see here, this is a line 1, line 2, line 3, 4, 5, 6 lines. Those 6 lines came from, if you see here, text and images. When I click text, we have five text and 1 image. That's what we have here. 5 lines of text and 1 images. Okay, so now you can clearly see how you can display. All others are just declarations. All right. This is a little bit of a reminder, and I'm going to start from scratch today again. Okay. So there is Xcode, and I am going to create a new project, and that is, oops, sorry, it's not app yet. Oh. Should be app playground. So we're going to play one more time today. Of course, from there you will have a first homework assignments from the Xcode. And then if we have time, then we can get into the real app. Okay, so this will be homework, I'm not sure, maybe homework 5, playground, and object orientation. And nothing to change right now. Next. And I am going to save this in this particular directory and create. So this is the same as the one that we looked at, right? I am going to close this. This is a very useful pane that we may from time to time to visit to fix something when we develop iPhone apps. Right now, if we click this, then it'll disappear so that we have a wider space. And this now we have this is editor, and left end there's another pane. Shows us right now this is just organizations of your file systems, and there are some others also. We're not going to do that all. I'm going to push this a little bit aside, and right now we have 1 image and 1 text. Therefore, in this emulator you have 1 image and 1 text. Okay. So what we'll do today. We're going to review a little bit of object-oriented programming in Swift. I know you guys already did in Python. The idea remains the same, a little bit more advanced here in this better language. What I am trying to do, this is also part of your homework assignments, so that you have to complete this. I'll go at my pace. So if you miss anything, then you can replay while you are completing your homework assignments. Right. So we have a person is a superclass, and then subclass of a person may be a student. Okay. So student is a subclass of a person. All right. So we have a person is a superclass and student is a subclass. Declarations for the class person could be, we can think of name, right? So name could be changed, or if you want to fix the name, then you need to start with let. but in this case, variable name. Type of name is string, right? Usually. And then it says person has not initializer. So we have to put here initialize. When I type init, then very nice. It is very nice to show so that we can take advice from this Xcode. So why not take this? It's init, because I declared the name only, one field in that variable. So I have a string here. Zheng, why? Okay. I thought there was another thing. Okay. So if it is highlighted very nicely, we can just hit enter or return key, then you can take it, right? So how nice it is. I just hit return key. It gives me complete, accurate lines of code. So this is a definition of the person. So person has only one field, name. And when we initialize the person, then we need to initialize any person with the name. There is no such a person with no name, of course, right? And then student is a person. So of course, students can inherit name from person. So we do not have to say about name here, all right? But we can say here variable major. So person has a major. Again here, there's no initialize. So if we say init, then this guy, I need to have this and this together, right? Because I have to get it from upstairs. So let's start with the major first. With that, I need to say major is my own field at the level of a student. But at the same time, student is a subclass of a person. So me as a student have every right to inherit anything from my father, person. Don't say that to your father. But in this programming, that is it, right? So we should say something here. I need to get something from my father, which is a super class. From the super class, which one that I need to get? Do I need to get a name init directly or init? I better to get the init. Okay. Then the way that I can get this major, then I can do here name string, and that name can be fit in here. So when I create an object of student, I can get student name and student major. That student major can be plugged in into the field at my level, students. But name for value name for student go up here. It goes into the init. It invokes init function from the super object, so it goes into here. So field the major will come here, and name of students will come here. That is our object orientation. Okay. If you want to create an object, for example, student 1, then you can create by this init. How you can do student, open and close. In this case, you need to get this. You need to get the name and major, because we say this init as name and major, so that we have a name and major here. So we simply say here, Chris, major, computer science for now. And we can do another variable, student 2, then that is also student, and string Eduardo, major CS, student 3. So we can create students, name Jessica Cyber. You can do that. I wanted to create more and more of this. And then finally you can say, oh, I have a variable student class which contains student 1, student 2, student 3, and more and more. So I wanted to put your name there, okay, at least. If your major is different, you can change it. Okay. And then here, or you can say this, I want to bring this inside this program rather than outside, okay? Here, inside. Within this program, this is all the declaration, right? Previous declarations I have here. And then okay, I'll take this out. What I will do here, I will make another like scroll view rather than yeah, if we have more and more, then we need to scroll view. Okay, within that scroll view, what I want to do is for each in this stud, for each in this stud, and I want to do text and what do you want to display in this text? For each, oh, I think I need to have here open and close. For each, it's missing. I'll do this. And in this text, one more thing here. For each from this list, and I would say a student. A student. I want to display in horizontal stack. And again here, close that. Okay. So what is an error here? So for each students, students should be in identifiable. Referencing, if I want to reference student STUD is a list here, right? That is a vector array. But I want to see for each students, therefore this student class needs to be identifiable. So I need to go back here. Not only student is a person, but we need to say identifiable. Okay. Then when I come back here, that error disappeared. And in this case, I need to say here missing. What do I want to write there for that text? I want to do stud dot, the first one is name. Okay. And then I may do another text, a stud dot major. So far that I have, right? That's what I have. Not text. So see here, Chris CS, Eduardo CS, Jessica Cyber. So that's so far that I have, right? Very nicely. What happens here is that I have a list of students in a vector, in a list. They're all in a vertical stack, so vertically stacked. The first item on that stack is image. From there, all others are scalable. So when I bring that down, it is scalable. Everything is scalable. Within this, in the middle range, what I did there here is from this array, for each element in that array, I call it a student. But this a student, for each student needs to be in horizontal stack. So whatever that I say here inside, horizontally organized. So name and major. name and major. Okay. In object orientation, not only this, we need to do, this is the only static aspects of object orientation. So we need to add behavioral aspects. So what are the behavioral aspects there? So we will have, for example, student has GPA, right? So we need to do compute GPA. So this is a function. Remember that when we declare the function, we need to say two names for one variable. So I can say maybe point, that first name is for the caller side, and the second name is my local side within this function definition. So I can say grade, all in an array integer. If I have that, then I can return a double. Then I need to compute here. Missing return. Sorry, I need to return. I need to return GPA. Of course, GPA is not defined, so I need to see here variable GPA. Initially, GPA type of GPA is double, because I said here double. And initially, that is 0.0. And then we need to compute, right? How we can compute GPA? A number of points divided, total points divided by the quantity, right? So so what we'll do here, we need to have a total. Total needs to be computed. Given numbers in array, all in integer, so total is also in integer. And initially 0. And then we can do for each is a reserved word. For each EA in grade, we're going to use this grade. This is the caller side variable. This is my side variable. Call the function variable, implementation variable. So we need to do here grade. And then total is nothing but the accumulate the EA value. Okay. So GPA is computed. Total divided by grade. Grade is an array, right? So how many elements in that array? Then dot, then there is a property, count. So it can count how many. Now this guy complains. I know what complaints is. This is an integer. Total is an integer. Maybe total integer. This will be a double, right? If we do the divisions. For example, 10 divided by 3, then 10 is integer, and 3 is also integer, but the outcome of that division is 3.33333. So we need to take that all into accounts, then we need to say double. So that will be returned. So this is one of those, right? So if you want to do then, when we create, yeah, this is created, that's fine. Okay. And I'll leave this a little while so that you can follow if you want to do. You can do one more here. Okay. What I want to do is I want to add one more function. This is your homework. And also here, add a list. I need to show to you the scroll of this. In order to scroll this, I think I need to at least 10. Then you need to add here, right? Student 1, 2, 3, 4, 5, 6. make sure that your name should appear here. Not only, I want to list not only yours there, I want to put here text a student dot, I want to call this function compute GPA. Compute a stud. Compute GPA, this. Click that. Very nicely, this guy says, we need to put the integer of those. So you can put 89.78.99. What is in there? No exact match in call to initializer. The reason is that this guy gives us what? What is the type of the value? Double, right? What is the thing that we want to do here? Text. So we need to put here string, and everything should be in string. So we have 88 point. This is no good. How come everybody has the same number? Right? So we have to, I want to do, before doing that, I want to put here GPA colon and then plus. So it is GPA colon 88.0. Everybody has the same GPA. Doesn't make sense, right? So we need to make something different. How can we do? We want to do here another the variable point 1 from integer dot random in integer, and I want to put there the point between 0 and less than 100, less than 101, and then this PT1 maybe here, 0.1. Then everyone has different, right? 89, 78, 99, and PT1 is a little different, right? If you want to see the PT1, then you can see here, print randomly generated number is PT1. To see that, oops, what is this? Cannot interviews. This not allowed in this print. Okay. But anyway, we will be able to see what is this, right? If you want to get another one more, then we can have here PT2, and rather than 99, we'll have a PT2 here. Then it'll be really different, right? If I rerun, yeah, every time when I run this, click this on the emulator, I have a different number, right? Okay. I need to create more. Okay. What I want to do, this scroll. This is a stack, right? This guy doesn't indicate. I think this is end of this stack. So here we need to put a frame, 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 and then height. Height maybe 75. That's too high. 65. Yeah. In this way, you may be able to see. If you have 10 of those, then you can see it more nicely. Then I would do background. Background. Background, and then color. Background. You can see here red. Then everything is red, which is no good, right? So what I want to do is I want to make another class here. I will do let the colors, which is the color, and we need to initialize it in an array. I can do red, green, blue, purple, pink. What else? Purple, red, yellow, blue, green, brown. Okay, that much. And I want to use this color here, but I would say randomly. So colors, if I choose color 2, for example, then all blue, right? Why? Because 0, 1, 2, the index number 2 is blue. So rather than hard-coded number, what I will do is I want to do random, right? Integer dot random. In that integer, I want to do zero dot dot less than the color dot count plus 1. No, sorry. Color. So I want to, this is the color list. I want to choose a color randomly from index 0 to the size of that array. So we can have that, right? It's a randomly. So if I do rerun, I would have different number every time. Oh, there's some same numbers. Why same number? Same color. Better have the different color each time. Yeah, like this. All 3 different color will be better. All right, this is your homework assignments, okay? Complete it. So what you need to do is you will have one more function. I want you to make that okay? So you need to put here, not literally like this, similar to the way that we call the functions. If you do not want to make the same numbers, then you need to make a randomly choose. But that random number should be reasonable, right? If that is a greater points, then 0 to 100. So I made that, right? So I wanted to make this text. Okay. All right? Question? No question, right? So we'll take a 5-minute break. There's a range of the random number. Yeah.
screen again?
I close it. Sorry. Okay, I'll give you a quick review of that object orientation. I prepared this slide, also available on your. The class is a blueprint of what we create our app components. Okay. For example, if we have a number of objects, then we need to make a blueprint. So we call this class. So usually in data mining or machine learning technologies, what they do is based on data sets about objects, we need to classify and make a rule, make a skeleton, make a blueprint. That is the data mining. We call that models in that case, there's classifications. But in programming languages, we cannot start from each single object to generate the class. In programming languages, we usually we define class first and instantiates. That's what we had, right? I'll bring that up. Where did I have here? Right? I created a class first, and then I instantiate. I cannot start from this. Hey, we have a Chris in computer science, Eduardo in computer science, therefore declare this first and then class. That is not possible in programming. We need to define class first and instantiation and do some work. Okay. So this is something that we did, right? We have a person, initialize it. Once we have a class person, then we can say, I can create the person object, which is A. A is an object of person class. Because we didn't have anything in this initial init function, we don't need to do when we instantiate. Here we did, right? Because to instantiate the students, as we defined here, the init function needs to take two variables, both in string, name and major. Therefore, we have here name and major. Methods and playground. Then we have a method. Method definition is the same as method in general, function in general. So there's a reserved word, func. We didn't have any modifier about that func. This is a typical func functions. In Swift, not only general function, but there may be some special functions. So you will be able to see it. So this is a little more complicated than Python language. You may be able to see that, right? This is a more formal language. Python is, if you see Swift, then you may be able to notice Python is like a toy. So this is a function, func function name. This function doesn't do anything. I think you need to have it here, open parentheses and close parentheses. Variable properties. So you have a variable here, name, which is a string, initialize, Johnny. Look at this, how many n's? And also like that. Subclass can be defined also. If we have a person defined, then you will have a student, which is a subclass of person. Okay. I think this is an error. I'm not sure why this. So class person has functions update, increase age, or get average age. So update. Two variables, new age and new name. This is a little awkward. Okay. And then there is a, this is typical, the class of your iPhone apps. The class name, given class name is called the view controller. So this view controller is, I think this should be uppercase V. View controller, there's a class name, is a subclass of UI view controller. So user interface view controller. There are lots of UI classes already defined by Swift and provided for you to use. So usually we simply use some classes for particularly the graphical emulations, graphical display. Then you don't really create graphics themselves, but you simply use it. That is the beauty of object orientation. So you'll get, once you open this initially in, that's what we will have in a minute. Then there is a, because this is a subclass always, you don't create your class dangling from given Swift environment. Anything that you create, you better put it in structure already provided. Otherwise, you have to develop, you have to define everything on your own. You don't want to, right? It's not possible. You simply, whatever you want to do, I want to plug this into gigantic, big environment. One way that you could do is this. This is the ones. Hey, this is my class, which is a subclass of a UI view controller. But UI view controller is one of a standard, one of a given. As far as you plug your class into it, you are directly, indirectly related to all others. So that you can simply, like here, you can do super dot view did load. A lot of typo. View did load. This function view did load is my function that I am trying to do that. What it does is that I want to view this when this view is loaded. So first view that you want to make should be done here. Whatever you want to do, then you need to put here. After that, by clicking buttons, by editing on a text field, you can do more and more interactions possible. But before you do that, if you want to set up something as your view is loaded, anything that you want to set up front, then you need to do that here. One of those is I want to inherit from superclass view did load. So view did load is already defined in the superclass. So everything is ready. Right now we do not know what is ready, but something that you need to do additionally, then you need to spell that out here. If you say super dot something. Same thing here. Did receive memory warning. This is the function name. This function name is not brand new that I want to create at, on my own at the level where I am currently, but because it is already available in somewhere superclass, I want to inherit it so that you need to say super dot same name. Then it can be inherited. Okay, so I'll stop this.